This is part 3 of our second 9-week review. Does this graph represent a proportional relationship? Let's look through the different parts that would make it a proportional relationship. First, does the graph come from the origin? Yes, it does. It hits the 0, 0. Second, is this graph linear? Does the graph form a straight line? Yes, it does. And third, is there a k present in this graph? To find the k, we would use the 3 given points and we would divide the y value over the x. The 6 divided by 5. Our next one is 12 divided by 10. And our third one is 18 divided by 15. If we divide each of these, we will get 1.2 for all three. So the constant of proportionality is 1.2. The graph is a straight line, meaning it is linear, and it originates out of 0, 0 being the origin, so we can confidently say, yes, this graph represents a proportional relationship. On this slide, we want to evaluate the following. We want to solve each equation for x. And starting off, we have 4 times the sum of x plus 11 is equal to negative 210. If we look to the left side of the equation, we should be able to identify the distributive property telling us to multiply 4 times x and 4 times 11. 4 times x is 4x. 4 times 11 is 44. And this is equal to negative 210. We want to solve the equation for x. And to solve the equation, we want to get x alone. So starting off, we want to get rid of the number that is furthest from the variable but on the same side. So we have 4 times x plus 44. Plus 44 we will get rid of by doing minus 44. On both sides of this, we want to do on both sides because we want to keep it equal. And on the left side, a plus 44 and a minus 44 are going to zero out of the problem and leave us with just the 4x. And that is equal to negative 210 minus 44, which is negative 254. Now our equation says 4x equals negative 254. We need to divide both sides by 4 to get the variable x alone. The 4 over 4 divides out to 1, leaving us with just x. And that is equal to the quotient that's found on the right side. Negative 254 divided by 4 is equal to negative 63.5. Our x is found to be equal to negative 63 and 5/10. We want to follow this same process with the problem underneath it. 8 times the sum of x plus 4 is equal to 148. Let's start off by doing the distributive property. 8 times x and 8 times 4. This will give us 8x plus 32 equals 148. We're going to divide the problem into left side and right side at the equal sign. And the first thing we're going to get rid of is the plus 32. To get rid of that, we're going to subtract 32 from both sides of the equation. When we do this, the positive 32 and negative 32 zero out, leaving us with 8x is equal to 116. Now we need to divide both sides by the 8 to get the x alone. 8 over 8 is equivalent to 1x, and that is equal to the quotient of 116 divided by 8, which is 14.5. So in our second problem, the x is equal to 14.5. The purse I've been wanting is on sale for 30% off the original price P. The sale price for the purse can be written as 0.70p. Which other expression represents the price of the purse? If you look at this problem, the original price is represented as P. P represents 100% of the price, but it's on sale for 30% off. So if the original price is 100% and I take 30% off, that means that I have to pay 70% of the original price. And this is where we get the expression 0.70p. The 0.70 is my 70%. So since I'm paying 70% of the item, or 0.70p, I need to find an expression on the left that is equal to the same thing. And as I look, I see the first one, I have 1p minus 0.30p. Those are like terms. So if I take that and I have one whole p and I subtract 0.30p, that is going to leave me with 0.70p, giving me my correct answer. But I just want to check B. B also has like terms. 1p minus 0.70p. 1p minus 0.70p is 0.30p. This definitely cannot be my answer. And as I look at C and D, there are no like terms. And since there are no like terms, I can't combine anything, which means those are the answers that they can, only answers that they can be, which are not equivalent to 0.70p, so they're not the answer. In this problem, we want to subtract these expressions. In order to do subtraction of these expressions, we have to be able to combine like terms. But the way this problem is written, we can't combine anything because of this minus sign located between the two expressions. In order to do this, we need to turn this into an adding problem. And in order to do that, remember that subtraction is adding the opposite. So this minus sign will become a plus sign, and the entire next set of terms inside the parentheses will become their opposites. I am going to leave my first expression exactly how it's written, negative 8x plus 20. The middle subtraction sign is going to become an addition sign, and my next expression is going to become opposites. 4x will become negative 4x, minus 2x is plus 2x, and plus 12 will become minus 12. Now that the sign in the middle is an adding sign, I can continue to combine like terms. Negative 8x is going to combine with negative 4x and positive 2x. When I combine these, I end up with negative 10x. Now I want to go through and I want to combine my constants, a positive 20 and a negative 12. Positive 20 and negative 12 give me positive 8. Negative 10x plus 8 is my simplified expression. Let's go to the next expression and practice doing the same steps. Starting out with the middle subtraction sign. We can't combine like terms until we get rid of that one subtraction sign. In order to do that, we're going to turn the problem into adding the opposite of the second expression. Let's leave our first expression as written, 14x minus 4. Our second expression is going to become a plus, and now everything will become its opposite. Negative 6x becomes positive 6x, plus 3x minus 3x, and minus 9 will become plus 9. Now I can combine like terms. Beginning with my variables, I have 14x, a positive 6x, and a negative 3x. When I'm done combining these, I will have a sum of 17x. Now for the constants. I have a negative 4 and a positive 9. When I combine these, I get positive 5. So my final expression is 17x plus 5. So as we look through these, if you come across an expression and the two expressions are separated with parentheses and a subtraction sign in the middle, we need to rewrite it as an adding the opposite. Solve the following equations. We want to find the value of x in each of these equations. Let's start with our first one. We have 8x minus 20 equals 12. In order to solve for x, we need to get x alone by moving everything from the side of x to its other side. First, let's get rid of the minus 20. To get rid of minus 20, we're going to add 20 to both sides of the expression. When I add 20 to both sides of the expression, the negative 20 and positive 20 zero out, leaving me with 8x equals 32. Now, I'm going to divide both sides by the 8 in order to get the x alone. 8 over 8 divides to 1, and 1x is equal to 4. Time to solve the second equation. 4x plus 15 equals 35. Let's look at the problem as two sides, a side with an x and a side without the x. We want to get the x alone first by starting with the plus 15. In order to get rid of plus 15, we're going to minus 15 to both sides of the equation. That is going to eliminate the 15 on the left, leaving me with just the 4x is equal to 20. In order to undo the multiplication with the x, we're going to divide both sides of the equation by 4, and we find that 1x is equal to 5. This week, Susie sold 12 dark chocolate candy bars and 18 milk chocolate for a splash fundraiser. Last week, she sold 15 dark chocolate and 22 milk chocolate. If she charged $1 for dark chocolate and $1.50 for milk chocolate, how much did she earn for the splash fundraiser? Let's start this problem by finding the amount of money she earned for selling the dark chocolate. First thing we need to know is how many dark chocolate candy bars she sold. So she sold 12 one week and she sold 15 the other week, giving us a total of 27. If she sold 27 candy bars for $1 a piece, that tells us that 27 times $1 each, she raised $27 for dark chocolate candy bars. Now let's bring our attention to the milk chocolate candy bars. First, how many did she raise or sell? She sold 18 one week plus the 22 the second week for a total of 40 sold chocolate bars. She sold these milk chocolate bars for $1.50 a piece. So the 40 chocolate bars that she sold times the $1.50 that one of them costs, and we find that she raised $60 on just the milk chocolate. The question wants to know how much she earned. So the $27 for the dark chocolate plus the $60 for the milk chocolate gives her a total of $87 raised selling the candy bars. On this question, we want to be able to define a rational number. We want to be able to explain its characteristics. First of all, a rational number sometimes terminates, meaning when I divide it out of its fraction form into its decimal form, it will have a terminating decimal. An example of a terminating decimal is 0.6 or even negative 1.43. Both of these are examples of terminating decimals. A rational number will sometimes repeat. Repeating decimals are also known to be rational. This includes 1.4 repeated or negative 0.16 with a repeated bar over the 16. So rational numbers sometimes terminate and sometimes repeat. But most of all, a rational number can be written as a fraction. A fraction with a non-zero denominator is a rational number. The TMS has rectangle tables with a length of x plus 2 and a width of 8. Which expressions could represent the area? We're dealing with a rectangular table that has a length of x plus 2 and a width of 8. If we remember back to how to find the area of a rectangle, the area is found by length times width, or base times height. And in this problem, we're given x plus 2 as the length, and we're multiplying that by the width of 8. Or the commutative property tells us that 8 could be at the front, and the x plus 2 can come to the back. This tells us that either C or D are the correct answers because they have 8 times the sum of x plus 2. Now we need to look to the second answer, and we need to use the distributive property to determine which one's next. And the distributive property tells me I'm going to take the 8 and I'm going to multiply it to both terms on the inside. So 8 times x and 8 times 2. 8 times x is 8x, and 8 times 2 is 16. So 8x plus 16 also represents the area. This leaves me choosing option C as my final answer.